Okay, for our algebra lesson 7.4 notes, we are now moving on to division properties of exponents. So let's take a look. You can use properties of exponents to divide if they have the same base. You can use repeated multiplication, which is called expanded notation, like they've done here, to simplify. So let's take a look at their example. We have 4/5 divided, remember a fraction is a division problem, by, I said 4/5, 4 to the 5th power divided by 4 to the 3rd power. So they expanded it into 4 times 4 times 4 times 4 times 4 because there are 5 of them. And on the bottom, on the denominator, they expanded it to 4 times 4 times 4 because there are 3 of them. So what we can do is if it's a 4 divided by 4, that's 1. So it cancels out. 4 divided by 4 again is 1. 4 divided by 4 again is 1. And we're left with 2 4s on the top. So 4 times 4. The denominator technically would have a 1, but we can leave it invisible. And so we have 4 squared because there are 2 left as your final answer. So here's what you probably could do. You could probably see this already. Instead of sitting here expanding it, you could notice that 4 to the 5th power divided by 4 to the 3rd power is easily done by subtracting exponents. So in an earlier lesson, you learned that if the numbers had the same base, like 5s for example, 5 to the 2nd times 5 to the 3rd, if they had the same base, you could add their exponents. That same rule applies when you're dividing, you can subtract. So if they have the same base, you can add exponents when you're multiplying. If they have the same base, you can subtract exponents when dividing. Okay, so here's just their quick example. It doesn't matter what the bases are. They could be a variable like a, and you would take m and subtract n. So a to the m minus n. So let's take a look at their examples. 2 to the 6th divided by 2 squared. 6 minus 2 is 4. So the base stays the same. You subtract the exponents. All right, again, 4 minus 7, but look what happens here. 4 minus 7 is a negative, and remember from a previous lesson, you can't have a negative exponent. So it is going to flip to the bottom into the denominator and become positive under a 1. So remember, all of the previous rules still apply. And then here's one with rational exponents. So 3/4, since the bases are the same, s's, you can take 3/4 and subtract 1/2 since we're dividing. See, they've done that here. And you're just going to use your calculator because you don't need to remember how to get like denominators and all of that. Now we're just going to use our calculator. But once you subtracted 3/4 minus 2/4, you get, well, 3/4 minus 1/2, you get 1/4. So s to the 1/4 power. They actually got common denominators first, but since we're going to use our calculator, you can actually skip that step. All right, let's go down and try to find the simplified form of x to the 5/2 divided by x squared. So since the bases are the same, they're both x's, we can take x and we can take the 5/2 minus 2. So I'm just going to type that into my calculator. I'm going to type 5/2, which to me is 5, ABC button 2, and I'm going to subtract 2. That's 1/2. So since that is 1/2, our final answer is x to the power of 1/2. All right, let's try our next one. There's multiple variables here, but if you're dividing, you look for the same base. So m squared divided by m to the 5th. So remember, we're only looking at the m's right now. M squared and m to the 5th. If we subtract 2 minus 5, you have m to the negative 3. That's going to be a problem, but let's get to that in a minute. N to the 4th and n to the 3rd. If you're dividing, you can subtract 4 minus 3, and you get n to the 1, because 4 minus 3 is 1. Okay, this is clearly not simplified. We have to keep going. M to the negative 3 cannot stay up top because you can't have a negative exponent, so it's going to go to the bottom under what would be a 1, but we've actually got this here. So m to the, now it's a positive 3 since it flipped to the bottom. N is still up top. It does not need to flip, so N is going to stay there. And you do not need to put the first power. Anytime you have a 1, we're just going to leave it hidden and visible. So N over M to the third is your final answer. All right, if you think you got it, let's go ahead and push pause and try the next 5 on your own. If you are not ready to try it on your own, I'll work it out with you, or if you're just checking your answers, fast forward and make sure you did this correctly. So y to the 3/4 divided by y to the 1/2, you're just going to take 3/4 and you're going to subtract 1/2 since we're dividing. And I would put that in your calculator, but you're going to end up getting 1/4 once you put it in your calculator correctly. So our final answer is y to the 1/4 power. All right, d to the 7/2 divided by d to the third means we're going to take 7/2 and we're going to subtract 3 because they're the same base. When you put that in your calculator, you should have gotten 1/2. So that means our answer is d to the 1/2 power. All right, C, I'm going to work out a little bit more with you because we have 2 variables being divided by the same 2 variables. So when I do this, it's going to be 6 minus, that is a hidden invisible 1. They wouldn't have had k there at all if it was 0. So since it's there 1 time. So we have 6 minus 1. So we have k to the 5th. J, 2 minus 5 is -3. And that is a problem. You cannot have a negative exponent, so this one is going to need to flip down to the denominator. So your final answer would be k to the 5th over j to the 3rd, because once you flip it, the exponent becomes positive. All right, on D, you have the a's and the b's, so let's do the a's first. So you've got a to the -3 minus 5. -3 minus 5 more is -8. B is to the 7 minus 2, which is 5th power. Okay, so the b to the 5th is fine. We don't need to flip that. So b to the 5th is going to stay in the numerator. However, a to the -8 is going to have to flip to the denominator to become positive. And once you do that, it is positive. So b to the 5th over a to the 8th. All right, last one. Notice they're already in alphabetical order. I should have mentioned that with the A's and B's. Always make sure you have them. Now this you can't help, but if they're left to right next to each other, they need to go in alphabetic order. So X, Y, Z. So x to the 4th and x to the 4th being divided, anytime you have all x's divided by the same number of x's, it cancels each other out. Just like we did up here in expanded notation. If they all canceled out, it would have just been 1. But if you don't remember that rule, but you remember that you're subtracting exponents, 4 minus 4 is 0. And if you have x to the 0 power, anything to the 0 power is 1. So that's actually an example of why it's 1, because they all cancel out. So I'm just going to cross them off, because I know that I'm going to have something, and 1 times anything is just whatever's left. So I'm just not even going to assume they're there. Let's do the y's. Y to the -1 minus -5. That's a little tricky. So that is going to be y to the -1 minus -1 minus -5 is positive 4. So y to the 4th. Then we've got the z's, which z here doesn't have anything, so that is a hidden invisible 1. So z to the 8th divided by z to the 1st, you can subtract 8 minus 1, which would be z to the 7th. So final answer is y to the 4th, z to the 7th. Nothing needs to flip to the denominator because we don't have any negative exponents. Okay, let's go on to the next page. The next page is scientific notation. So you're going to need to know how to do this too. This is totally new, so scientific notation, unless you learned it in science, which we've kind of debated that. I'm not sure. So they're going to tell you exactly, this is a word problem, kind of similar to what you're going to have on your Math Excel. Population density describes the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7th people. This is an example of when you would use scientific notation, when you're talking about a very large population. So the area of Angola is 4.81 times 10 to the 5th miles squared. So what was the population density? So again, one thing I want you to recognize is these are in proper scientific notation because the first number is between 1 and 10. And this one is also in proper scientific notation because the first number is between 1 and 10. If we know that this is going to be a division question, because if you're trying to find population density, you're dividing how many people there are by the space that they're allowed. So population density would be this divided by this. So they have taken that and they've written it out for you as a division problem. So 1.21 times 10 to the 7th divided by 4.81 times 10 to the 5th. This is how they do it. They take the first section, just like they did here, and divide it. When they divided that, they got about 0.252. And I think it was an irrational number, but they rounded it to the 2 at the end. So 1.21 divided by 4.81 is about 0.252. Then they took the bases that were the same, 10 to the 7th divided by 10 to the 5th, and with our new rule of subtracting, they got 10 to the 2nd because they subtracted 7 minus 5. Okay, but this is not proper scientific notation because our first number is not between 1 and 10, it's 0. So they moved the decimal one place to make this number 1 bigger, which means you need to make your exponent 1 smaller. Okay, so 2.52 times 10, they wanted it in standard form, standard notation. So if they wanted it, okay, let me back up. If they wanted it in scientific notation, it would have been 2.52 times 10 to the 1st power. That's proper scientific notation. But they wanted it in standard. They want to know, okay, I don't want the times 10 to the, I just want the population density. So in order to move it one more time bigger to get rid of this altogether, they moved it one more time because it was 10 to the 1. And that's how they got the final answer of 25.2. But we are not going to worry about standard form. We're just going to write them in scientific notation. So let's try a few of these. And I know it says got it. You can actually push pause if you want to try on your own, but I will work out these with you since it's a little bit different than what they did here. So step 1 is let's divide these two parts that we know. 5.2 divided by 1.3. So 5.2 divided by 1.3 is 4. Came out exact. And I love it because 4 is already in scientific notation because it's between 1 and 10. Times 10 to the power of, remember, since the bases are the same, we are going to subtract their exponents. So 13 minus 7 is 6. So there you go. 4 times 10 to the 6th. Done. All right, if you think you got it, maybe pause the video and try 25 and 26. All right, I'm going to keep going. So 3.6 divided by 9 in my calculator. 3.6 divided by 9 is 0.4. That's a problem. That's not scientific notation. Let's go ahead and see what we've got here, though. If you take negative 10 minus negative 6, negative 10 minus negative 6, that would be negative 4. Let's just double check. Negative 10, negative 10 minus negative 6. Yeah, negative 4. So 10 to the negative 4th for now. But we know this is not done because our first number is not between 1 and 10, it's 0. So I'm going to move the decimal one place to make this number bigger. So I need to make my exponent one number smaller. So proper scientific notation would now be 4, since I moved it to after the decimal, times 10 to the smaller than negative 4 is negative 5. Okay, last one. Take this and go ahead and divide it. So 6.5 divided by 5. 1.3, I love it because it's already in scientific notation. We won't have to change it or convert it. Times 10 to the power of, let's subtract, 4 minus 6 is negative 2. And it's okay for scientific notation to have negative exponents, just not when you are simplifying regular exponents or variables. Okay, the next section is also new today, but I think you guys will hopefully get it because it's very similar to what we've been doing. Anytime you have a fraction and it is in parentheses and the whole thing is raised to the power of 3, that means there are 3 sets of whatever that division problem was. So that would be in expanded notation, x times x times x over 3, y times y times y. So 3 of them and 3 of them. So the shortcut is anytime you have parentheses, you're basically, I'm going to use the word distributing again, this little exponent to both the top and to the number that's in the bottom. Both the numerator and the denominator get a 3. So I don't want you to forget that if it's a fraction, both the numerator and the denominator get distributed that little exponent. So here's the examples of it. If they have a over b to the n power, then a is to the n power over b is also to the n power. Okay, here's it with actual numbers. 3 gets to the third power, which 3 to the third power is 3 times 3 times 3, which is 27. And 5 also gets raised to the third power. So 5 to the third power is 5 times 5 times 5, which is 125. Okay, 5 goes to the x, 5 goes to the y, so that is it simplified. 1/2 goes to the a and 1/2 goes to the b, so here is it simplified. Okay, so let's try one. It gives us multiple choice. Okay, guess it's helping us out a little bit on the multiple choice one. So for multiple choice, we know that z has a 2/3 already, and we are now distributing it a 3, and the 5 also gets raised to the third power. So let's not worry about the denominator right now. Let's not worry about the bottom. Let's just look at the top, what we've got here. So we have z to the 2/3 getting multiplied by a 3. And remember, anytime it's a whole number, it's the same thing as over 1, and you can multiply straight across, straight across. I don't know why I'm teaching you this, because you can also just use your calculator. So on the top, we've got z to the 2 times 3 is 6, over 3 times 1 is 3. That is not simplified. 6 divides by 3 evenly and becomes z to the 2. Again, I could have just multiplied this in my calculator and it would have given me 2 because it would have simplified it already, but 6 divided by 3 is 2. Okay, now let's look at the denominator. We still have a denominator here, 5 to the third power. I would normally say, okay, you're done, because z and 5 are not the same base, so we can't subtract, but that looks like a 2, so I'm going to make it a z. But we can simplify what 5 to the third is. 5 to the third means 5 times 5 times 5, which you can do in your calculator, but it's going to end up being 125. So let's see if that's one of our choices. Did I do it right? Here we go, D. So D is the right answer. All right, if you think you got it, go ahead and pause the video. If not, we'll move on to trying this got it together. All right, this little exponent 2 is going to go to the 4 and to the x to the third. When it goes to the x to the third, these two get multiplied in. So I'm going to start with the numerator. We've got 4 squared. The denominator, x, already had a 3, so it's going to get multiplied by the 2, and it's going to be 6. All right, the only thing left we can do is we can simplify what 4 squared is. 4 times 4 is 16 over x to the 6th. That's all we can do. So that's the final answer. All right, let's go ahead and work out some that are a little harder, but using the same strategies we've been doing. So now we have a -3 on the outside of all 3 of these terms, these bases. So we need to distribute this -3 exponent to the 2 and to the x to the 6th and to the y to the 4th. So let's just do that step by step. Let's not work it out yet. Let's just write it. 2 gets a -3 exponent. X gets a -3 exponent, but it already had a 6 on it, so these get multiplied. -3 times 6 is -18. On the bottom, on the denominator, we've got the same issue. Y already had a 4 on it, so these get multiplied. 4 times -3 is -12. Okay, let's look at this. There are issues with this one, and this one, and this one. So remember, you can't have negative exponents, so we're going to need to flip-flop these spots. 2 to the negative third is going to flip to the bottom, to the denominator, and become positive. Remember, once you flip it, it's no longer a negative 3, it's a positive 3. X to the negative 18th is also going to go downstairs. And I'm going to make it a positive 18 because once it flips spots, it becomes positive. And y to the negative 12th is going to go flip spots too. So if it was in the denominator, it's going to move up to the upstairs, to the numerator, and then it's going to become positive. So we would be done because we don't know what y is and we don't know what x is, so those have to stay. But we do know what 2 to the third power is. 2 to the third power is 2 times 2 times 2, which is 8. So our final answer is y to the 12th over 8 x to the 18th. All right, if I'm going too fast, be sure to slow this video down or go back over it and try it on your own and then skip ahead to see that you got it right. This is the got it. Go ahead and pause it and see if you can do this on your own or wait for me to go through it with you. Okay, the negative 2 is going to get distributed into the A and to the 5 and to the B. Be sure you guys are distributing it to every single base, all the things that I'm going to say touch the ground. So A gets a negative 2. On the denominator, 5 gets a negative 2. And B gets a negative 2. And once again, we have an issue with all 3 terms. So we're going to flip-flop all their spots. A to the negative 2 is going to go to the denominator to become positive. 5 to the negative 2 is going to go to the numerator and become positive. And B is also going to flip up there. And the only thing we have left to do is you can actually work out 5 squared. 5 times 5 is 25. Then you've got your B squared over, down here you've got A squared.